This is about solving rational equations. And so when I say rational, I really mean fractions. Okay. You're going to use rational a lot of times in this course. And when I say that, I want you to think fraction. Okay. And I know nobody really likes fractions. So what our goal here is today in solving these rational equations is to really figure out a method on how to solve this so that we can eliminate the fractions and end up just having some other type of equation, whether that be linear or quadratic or cubic or whatever. So what does that mean on how we get started? Well, first, we want to figure out the LCD, or the least common denominator, for this rational equation. So we have 5 over x plus 1 minus 4 equals 5. Our only denominator here is x plus 1. So when I'm thinking about LCD in this case, or in all of these cases where we're solving rational equations, I'm not really thinking about a number. I'm thinking oftentimes about expressions. And so because this is our only denominator, this happens to also be our LCD. Our next step is to change all of these terms to have a denominator of x plus 1. Okay, so we're going to take each term individually. Let's start with 5 over x plus 1. And every time I write a term down, I'm asking myself, does it have the denominator x plus 1? And if not, what do I need to multiply by to make it have that denominator? In this case, we already have the denominator x plus 1, so this term's going to just kind of stay as is. Well, let's consider our next term. We've got minus 4. First, I think that would be helpful to write 4 as a fraction, so we're going to write it as 4 over 1. And again, I'm thinking I've got the denominator 1, but I need it to have the denominator x plus 1. So I've got to multiply 1 times x plus 1 in the denominator. However, in order for this to be equivalent, and you haven't changed the problem any, you've got to multiply the numerator also times x plus 1. Okay, so that's what you're going to multiply by here. Because x plus 1 over x plus 1 is really just 1. All right, so we haven't changed the problem any. Let's bring down the 5. So we're bringing down our equal and our 5. Again, I'm going to write 5 over 1, and this is kind of the same question. I've got 1, I need x plus 1, so I'm going to multiply the top and the bottom by x plus 1. Our next step is to write all of this with the x plus 1 as the common denominator. So this is going to be 5 over x plus 1. And I'm going to write this entire numerator all together. So 4 times x plus 1. We'll do distributive property on the next step. And then I'm going to write these two together. So this would just be x plus 1 because 1 times x plus 1 is x plus 1. And I'm going to do the same thing on the right-hand side. So this would be 5 times x plus 1 over x plus 1. Now, don't go canceling things here because that, as far as like, you don't want to cancel out like x plus 1 and x plus 1 because we already knew that. We know that it cancels. We added that in there because we needed to. And the reason we needed to is because now that we have denominators that are all the same, we can multiply everything by that x plus 1 LCD. And what happens is when you say x plus 1 times this term, this x plus 1 you're multiplying by and the denominator cancel out. And so it's like distributing to each one. And when you do that, that x plus 1 here is going to cancel with all the denominators, which is fabulous because the whole point of this was to get rid of the fractions because you don't like fractions and I don't either. That's why we do things like this. So because that happens, now we're just left with all the numerators. Let's look at that. We've got 5 minus 4 times x plus 1 equals 5 times x plus 1. And if you wanted to take that step to go ahead and distribute, that's totally fine. I just brought it down and now we're going to distribute. So we've got 5. We're going to obviously distribute the negative 4. Just be really careful here. That's going to be negative 4x. And negative 4 times 1 is negative 4 equals 5 times x is 5x plus 5 times 1 is 5. This is now a linear equation. Why is it linear? Because looking at our variables, we just have x obviously raised to just the first power. So that means it's linear. In order to solve a linear, we're going to just solve for x. So get all the x's on one side, the numbers on the other, and then divide. We're not factoring here because it's not x squared, and we're not setting it equal to 0. So let's combine our like terms first. We've got negative 4x, and 5 minus 4 is just 1, equals 5x plus 5. Now we're moving our number over. Sorry, our variable over. So we're subtracting 5x from both sides. That's negative 9x plus 1 equals 5. Subtract 1, we get negative 9x equals 4. And divide by negative 9. And that's going to give us x equals negative 4/9. So the answer can come out of fraction. That's totally fine. But we want to eliminate those fractions so that we don't end up having something crazy to deal with. Okay? All right, so that's one example when the denominator is two terms, x and plus 1. Let's look at one that ends up working out a little bit differently. So our next one is solve 5s plus 360 over s equals 85. Okay, so again, let's write out our denominators here. Our denominator, our only one, is this s. So that ends up being your LCD, is s. I don't love that we're dealing in s. Let's just not get confused with s and 5, okay? All right. What does that mean we do next? Now that we've got our LCD, we are trying to make each term have that denominator of s. So our first term is 5s. We want this to have a denominator of s. So it has an s in the numerator, but this is just over 1. So our denominator is just 1. So what do I need to multiply by here so that our denominator has an s in it? And that would obviously just be s. And whatever I multiply the denominator by, I need to multiply the numerator by. So multiplying the top and bottom by the same thing. Okay, moving on. Look at our next term. We've got plus 360 over s. Luckily, that already has the s we need, so we can keep that and don't have to multiply anything there. And then we're going to bring down the 85. So equals 85. This is 85 over 1. And I need to multiply something by 1. And what do I need to multiply there? I need to multiply s. And again, s over s. Okay? All right. So let's simplify this. This would be, again, I'm just going to write the top. And then I'll simplify on the next step. 5s times s. These s's. Just make sure they don't look like 5s, right? 5s times s over s plus 360 over s, goodness, equals 85 times s over s. Okay, look across there. All our denominators are the same. And so now that they're the same, we're multiplying everything times s, essentially getting rid of all of our denominators. So this s is going to cancel with that one, and that one. And let's write our simplified version of our problem in our next step. So 5s times s is 5s squared plus just the top, 360, just the numerator, equals 85s on the right-hand side. Okay, stop and ask yourself, what type of equation is this? So our highest exponent on the variable here is 2. So this is a quadratic. This is a quadratic. And if it is a quadratic, you need to set it equal to 0 and solve. Okay, so this is a different process than the previous one because that one was linear. This is quadratic. So our next step is going to be setting this equal to 0. We're going to do that by subtracting 85s from both sides. That'll be 5s squared minus 85s plus 360. Notice I put it in descending order at this point. Okay, there's actually another trick we can do here. It's not really a trick, but it's something you need to notice. And that is that all three of these terms are factors of 5. So we can actually factor a GCF out for the whole expression here. And that would be 5. So if we take 5 out, we're dividing by 5 for each one of these. That's going to give me S squared minus 85 divided by 5 is 17S plus 360 divided by 5 is 72 equals 0. Honestly, y'all, we're very happy about this because 360 was a really big number. That would not have been so fun. You could have done it, but it would have taken a little longer. Okay, and then here's another little trick to do. You don't really need to save this 5, okay? If that was an X, this would be a whole different conversation, or an S in this case. But in this case, I can just divide out the 5, and that's going to just leave me with this, okay? So 5 over 5 cancels. This is going to equal 0. So here's what we're going to do. We're going to bring this up here so we can factor for our next step. So this would be S squared minus 17S plus 72 equals 0. And now we're factoring. So S squared, 2 blanks, plus 72 equals 0. Keeping our first and last. Our A is 1 times 72. So 1 times 72 obviously is 72. And we need it to equal adding to negative 17. So this one is a little tricky because we have a positive 72, but then our B is negative. That means our signs are the same. They are the same, and they're both negative. Okay, so when we're creating our list here, we need to keep that in mind. So 72 divided by 1 clearly is not going to be 17. 72 divided by 2 is 36. That's not going to give us 17. 72 divided by 3 is 24. That's not going to give us 17. Divided by 4 is 18. That's not going to give us 17. 72 divided by, what do we have here? 5, 6 is 12. That's not 17. 7 doesn't work. 8 is 9. There we go. 8 times 9 is 72. What are my signs again? They're both negative. They're both negative. Okay? Because negative times a negative is a positive 72. And then negative 8 plus negative 9 is negative 17. Okay? All right. Now that we've got that, we're putting these two in the blanks. So negative 8S, negative 9S, group. So we're going to group the first two, group the second two. I'm putting a little plus sign so that we know this isn't multiplying. And now we're factoring out our GCF in each group. That's just going to be S, divide by S, and you get S minus 8. In the second group, really important to remember that the GCF is always the sign of the first term. So this negative has to come down, and we're factoring out 9 here. And if we're going to factor out a negative 9, we've got to divide by negative 9 to get these signs working out right. So this is going to be S minus 8 equals 0. This will give us S minus 9 and S minus 8 equals 0. And then we're setting each one of those equal to 0 to solve. S minus 9 equals 0. S minus 8 equals 0. S equals add 9, you get 9. Add 8, you get 8. Now, there's one thing I did not talk about in the previous problem that I want to talk about with this one. It doesn't end up working out any differently. These are our answers. But in future problems, you're going to have to do a little check, okay? What do I mean by that? That means that these are our potential solutions, but we don't know for sure if there are solutions until we check to see that it doesn't make the denominator 0. What do I mean? Remember that in math, you cannot divide by 0. And since we have a variable in the denominator, in this case just S, if S was equal 0, this whole thing would be undefined. So it would not work. You could not use that as an answer. In this case, S is 9 in one case. So if I divide by 9, that's not dividing by 0. So that 9 is good to go. Same thing with the 8. If I divide by 8, that's not dividing by 0. So you're good. So 9 and 8 end up being our solutions. However, just keep in mind, you can't divide by 0. So we're going to talk about that in our next two examples.